Hello everyone, today let's take a look at QP 154, pretty simple conditional probability question where we basically have n men and m women in a bowling club. Two members are randomly chosen to go to the state tournament. And then after they're selected, we have this press conference in which a reporter asks the president of the club if at least one woman was selected, to which the president truthfully replies yes. So what is the probability that both members selected are women, given that basically at least one is a woman? So we're essentially trying to find the probability of two women being selected, given basically at least one woman was selected. And just by the definition of conditional probability, which we've talked about a good amount at this point, this is just the probability that two women are selected and basically at least one woman is selected divided by the probability that at least one woman is selected, right? Now, obviously on the top here, in order for two women to be selected, it's obviously implied that at least one woman is selected, right? So we can just write this as basically the probability that two women are selected on the top here. Now these two probabilities here are very simple to calculate. The probability that we select two women, well, first of all, how many different ways can we choose our group of two people? Well, we have n men and m women, right? So in total, we have n plus m choose two different ways to select them. And of those, the only ones which include two women exclusively are going to be when we select two from our group of m women, right? So that's just going to be our probability of woman-woman. Now, what's the probability that there is at least one woman selected? Well, again, our total number of ways to select these two people for the state tournament are going to be n plus m choose two. And then the number of those selections that have at least one woman, well, you could think about it in one of two ways. We could either take n plus m choose two, right, our total number of ways to choose people, and basically subtract off all the cases where we only have basically men. So how many ways can we choose men? Well, it's going to be n choose two because we have n men, right? Or equivalently, you could think about it as basically if we have at least one woman, that means that we have basically one man and one woman. So n choose one times m choose one, or we could have basically two women. So m choose two. Because in order for there to be at least one woman among the two selections, we either have basically one woman and one man, or we have two women, right? That's what at least one woman means. So these two things are equivalent right here, this one and this one. But either way, it doesn't matter. When we plug in those values up here, you can see that this n plus m choose two is going to cancel because we're going to have it in both of our expressions. It doesn't really matter, right? So we can just write this as basically m choose two, right? The probability of woman, or the number of ways to choose two women, divided by basically the number of ways that we can have at least one woman, which was n plus m choose two minus n choose two. Or again, you could also write it like this, whichever way you want, and you could simplify it further, but this is basically going to be the final answer right here.